So when we're looking at fractions, which we've seen before, there are a few different rules to combining fractions and splitting up fractions and cancelling. So in combining fractions, what I'm thinking about here is two fractions, let's say a over b and c over d, and I want to add these up. Okay. Now, it should be relatively straightforward to do this if we had numbers in here, but here we might have algebraic expressions. The idea here is to actually rewrite this by multiplying both of these fractions by d over d, just multiplying by 1 effectively there. I'm allowed to do that and do that for both of these. And the second one I'm going to multiply by b over b. Again, I'm just multiplying by 1 effectively. And I know how to multiply fractions like this. It becomes AD over BD and CB over BD. And now that I'm on have a common denominator, the denominator is the same, I know how to combine these two fractions. I simply add up the numerators. AD plus CB all over BD. So if I had these as expressions, I could maybe simplify this numerator and I'd have a single fraction. I've combined two fractions into a single one. Okay, so that's combining fractions. The one thing to remember there is, although this is a foolproof method, multiplying this one here by d over d, the denominator of the second fraction, and multiplying this one here by b over b, the denominator of the first fraction, that will always work. It's not always the most efficient way of doing it. In fact, what we're looking for as a common denominator is the lowest common multiple of the two numbers b and d. BD is in fact a multiple of b and d, but it might not be the lowest common multiple. So I'll do an example just to show you what that looks like. So the example here is an example where I have two expressions. So these fractions are x plus y over xy squared, and I want to add x minus y over x squared y. Okay, so I could take the denominator here, multiply the top and bottom by that number. I could then take this denominator and multiply the top and bottom there and combine them, just as I did before. In fact, what I want as the denominator is just the lowest common multiple. So I want a number which is certainly a multiple of this, x times y squared, and also a multiple of x squared y. They're not always easy to spot. This one's not too bad because I notice that x squared y squared is certainly a multiple of this. It's just x times xy squared. And it's certainly a multiple of this. It's x squared y times y. And so what I've done here, this first expression, I've simply multiplied the top and the bottom by x. So just think about this fraction here. If I were to cancel out the x and one of the x's here, I would get back to this expression. The second expression, to get it over this common denominator, I multiply by y. Again, think about the y's cancelling and you get back to this expression. And now I've got a common denominator, I can combine those two simply by adding up the numerators and putting it over that common denominator. And there's a single fraction. It's not the simplest form. I could probably combine some of these terms. I could expand this using the distributive law and combine some of these terms, but it's a single fraction. That's the point here. I've gone from two fractions to a single one. Okay, so that's combining fractions. In general, it's just a generalization of a common denominator. If I want to split up fractions, so splitting a fraction, here I think about having an expression like a plus b over c, and effectively it's the reverse of what I've just done. This is actually just a over c plus b over c. It may be that this leads us to a simpler expression than this one here. Okay, so splitting up fractions is relatively straightforward. When I've got a single denominator here, both of the a and the b can be split up. And I can only do this if this is an addition. I can't do this if it's a multiplication. It could be an addition or a subtraction. And the last thing I want to just mention, as well as combining and splitting fractions, is cancellation. So with cancellation, I could have an expression which is a times c over b times c. And in fact, that's the same as a over b times c over c, but c over c is 1. So this would actually be a over b times 1, or just a over b. We think of this as just cancelling out the c where we have. And this is only going to happen if we have a common factor. It can't be an addition here. You can't cancel out a plus c over b plus c. If I had that kind of expression, there is no common factor in the numerator or the denominator. It is not allowed just to cancel out the c's like this. That's absolutely not true. It's only when we have a common factor in the numerator and the denominator that we're allowed to do this. Okay, I'll just do one quick example. Uses a few of these different rules. So this example is a fraction 5x plus 4 over x squared minus 2x minus 7 over x minus 2. So what we're going to do is combine these two fractions into a simpler form. The first thing I would always do is think about the denominators and actually factorize those themselves. So we've learned how to factorize. We look for common factors, and here we have a common factor of x in both of these terms in this denominator. It's x times x and x times minus 2. This other fraction is fairly simple. And now when we combine these fractions, what we're looking to do is find a common denominator between the two denominators. Well, here's x times x minus 2. Here's 1 times x minus 2. The common denominator will be, in fact, just x times x minus 2. Because if I then rewrite this in this form, all I've done there is this, with this second fraction, is multiplied the denominator and the numerator by x. I'm allowed to do. I then have a common denominator. I can combine these two fractions. So combining these two fractions would give me 5x plus 4 minus 7x all over this denominator, x times x minus 2. And finally, we're not quite finished because there's a bit of simplification we can see here. In fact, this 5x and the minus 7x, using one of the laws of algebra, we can combine those two to give minus 2x plus 4 all over x times x minus 2. And it looks like we're almost there. In fact, there's one final step, because minus 2x plus 4 can actually be factorized. There's a 2 factor in both of these expressions. And if we think about it a little bit, what I'm going to do is take out a minus 2, because that gives me, rather miraculously, the same expression, this x minus 2, as on the denominator. Just think about that distributive law. It takes minus 2 times x, and then minus 2 times minus 2 is plus 4. So these two things are exactly the same. I now have two factors on the numerator and the denominator that is exactly the same. I can cancel these two out, and the final result, if I cancel these two, is simply this rather complicated expression of two fractions, in fact, equals minus 2 over x. A much more simple expression using a lot of the different laws of fractions and algebra.